work on this homework during the block period on Thursday after your quiz. So first things first, let's talk a little bit about what we ended class with on Tuesday. Rate of change of position. Rate of change means derivative. Rate of change of position with respect to time. Now, that is going to be velocity. That's how we think of the rate of change of position. If this is the position equation, its first derivative, rate of change, is velocity. All right, but however, it's not always written in that derivative notation. So we got to think about our notation. It's going to change up a little bit. So I take the derivative with respect to time of position. So notice what I said. This is a derivative with respect to time. That means I've given an equation and it's dependent on time. Time is the independent variable. Position depends on what time is. That is written as ds dt. All right. The rate of change of velocity, rate of change again means derivative. The rate of change of velocity with respect to time is acceleration. So for us to write that correctly, the derivative with respect to time of velocity, you write as dv dt. That's going to be my acceleration. Again, going back and reviewing, the average rate of change, if it's any kind of function, and it has to be on a closed interval, f of b minus f of a over b minus a. Average velocity is average rate of change of position. So our average rate of position is s of b minus s of a over b minus a. Instantaneous rate of change is the derivative of position, which is velocity. So its velocity, its notation is s prime of t, which is velocity. You will see us start using this notation also. The instantaneous rate of change means I take the derivative of position with respect to time. So be ready for that type of notation also. These two symbols mean the same thing. All right. Now then, remember, we're trying to convert what we're reading into notation. So let's see what happens if we're given a situation where we've got to write what these words mean. Newton's law of cooling. This law states that the rate of change, okay, so that's the derivative, of temperature of an object is, we know is in math means equals. Proportional means there's a constant of proportionality. There will be a constant proportionality to the difference between the object's temperature and the temperature of the surrounding medium. Okay. Now then, first of all, we've got to ask a question. How does temperature change? Over what common interval? Well, we watch temperature change over time. So if I'm going to find the rate of change of temperature, I'm finding the rate of change of temperature with respect to time. Because we measure temperature over time. So here we go. So I know I have temperature, and I know I'm going to do something with it. But it tells me that the rate of change of temperature is. It's giving me a relationship. So rate of change is derivative of temperature with respect to time is proportional, means a constant proportionality. So I have K, the difference between the object's temperature and the temperature surrounding medium. So notice that this is a little bit different notation. We're gradually taking these words and making a relationship with them in mathematical terms. Here are my clues. Rate of change of temperature. So this is rate of change of temperature. How to think about how does temperature change? Well, temperature changes with respect to time. With respect to time. Proportional to the temperature and the temperature surrounding medium. All right. You try this one and see if you can figure out how to write that notation, and we'll talk about it in class on Thursday, see if you got it right. Okay, so the next rules that you have to learn for your derivative rules, so far you have the constant rule. So I'm going to use a little bit different notation so you get accustomed to it. The derivative with respect to x of a constant is 0. You have a power rule. So the derivative with respect to x of x to the n is n x to the n minus 1. The derivative with respect to x of sine x is cosine x. And the derivative with respect to x of cosine x is negative sine x. Oops. Sorry. So far you have the constant rule, the power rule, and you got 2 trig rules. So we know that we have these rules, and this is a little bit different notation. I'm not using function notation, I'm using derivative with respect to x. Remember, this was a derivative with respect to time. This one's going to be change of area with respect to s. So be careful. Read your problems carefully. Now, here I'm in derivative function notation, so I'm probably going to write my derivatives as in function notation. The product of 2 differentiable functions f and g is itself differentiable. Moreover, the derivative of f times g is the first function times the derivative of the second plus the second times the derivative of the first, and they write this all out. Well, in order to get you to help you remember this, I kind of write it in words also. So h prime, since this is the product of 2 functions, I can FOIL this out, or I can use this what's called a product rule. And they gave us a simple one to start with so we can easily follow the process. But these are going to become more complicated, and you're going to want to know the product rule instead of how to multiply it out. Okay, so the derivative of a product of 2 functions, the operation going on between these 2 is multiplication, is first times the derivative of the second plus second times the derivative of the first. All right, so this is considered my first function. This is considered my second. All right, so my first is 3x minus 2x squared times the derivative of the second plus the second times the derivative of the first. Then you can simplify that. And in simplest form, it will be negative 8x minus 18x squared. So it's a little bit faster to do it this way than it is to FOIL it and then take the derivative. It will save you steps. So first times the derivative of the second, oops, forgot my negative sign right there. Go back and check. Plus second, oops, sorry, no, I had it right. I apologize. First times the derivative of the second plus second, I miscopied it. Should be a 4 there, times the derivative of the first. All right, so again, always go back and check your work, which is what I'm in the process of doing here. Minus 16x squared. All right, so that means it's going to be negative 24x squared. Okay, everything looks good. And I hope you know where I got that negative 4x from. All right, next page. The next rule is called the quotient rule. And this didn't come through when I printed my notes. Let's make that a subtraction sign. So the quotient rule is when you have a polynomial in the numerator and the denominator, and you know you can't simplify anymore. So the quotient rule, if f of x equals h of x over g of x. Well, another way of writing f of x is saying this is top and this is denom, standing for denominator. So f prime of x, the derivative is denom times the derivative of the top minus top times the derivative of the denom over denominator squared. All right. So top is for the numerator, denom is for the denominator. So this is my top, and this is my denominator. All right, let's try it. So y prime is denom, x squared plus 1, times the derivative of the top, 5, minus 5x minus the top, times the derivative of the denominator, over the denominator squared. 5x squared plus 5 minus, I'm going to go ahead and multiply before distributing my sign. So 10x squared minus 4x over x squared plus 1 squared. So that's 5x squared plus 5 minus 10x squared plus 4x all over x squared plus 1 squared. So see, I'm just doing a bunch of algebra now. So now I have 5 plus 4x minus 5x squared over x squared plus 1 squared. All right, two important rules taking the derivative that we've added to our list. We now have a product rule and the quotient rule.